in the previous like I have explained till the particular one with the GPU, but now like we'll go to the next session where the text classification and a text image matching and image classifier. Like I'll cover. I'll try to explain these three concepts in this one. So I will follow the step by step where our sentiment analysis and the sentiment similarity will be like I have the demos here. Like I'll be sharing this first, followed by fine tune the models and then the named entity recognition, and post that the image classifier and zero shot classification. These five part I'll cover in this video. So if we go to the start, then the AutoML, where the detection with sorry, this is the other one. Yeah, here it is. The Auto ML for the text, the quick start is this one, and here the model predictors, multimodal predictors can solve a problem where the data is either the image or text or in numerical value or any type of features. Like it can handle like all kind of data. And to get started with the first demonstration how to use the problems on the content way or the contextual way, we used two classical NLP problems that purpose this demonstration. First one is sentiment analysis and the sentiment similarity. These two will be performed. For that, like first we need to import the AutoGluon multimodal. Once the multimodal is installed, then we can go and install the AutoGluon and the torch version and and the transformers as well. Once those are done, then we have to install the torch audio and the torch vision, so that they can identify other kind of the audio file extraction or a video thing, so they can be able to handle all those. Then we simply upgrade the AutoGluon. Once AutoGluon upgradation is done, this is to kill the get trip commands. If you take the more minutes, then it's a command where it's possible, and we import the numpy and matplotlib dips in the warning as well to ignore the filter warnings. And we see we fetch some random sets according to the model, and here we go for the sentiment analysis task. And once we consider the Stanford's sentiment tree bank is the data where we'll be performing the data set on this. So here's should consist of a movie reviews, their associated sentiments given a new movie review or something. The goal is to predict the sentiment reflections in the text, where the reviews are the labels as it one, and they convert the positive opinion as label 0 means the negative opinion about the movie. So this is the data set for that, and the sample data sets and other things. So yeah, this is all about the importing and the training data. So once the training data is done, then we need to evaluate the model. So it's a predicted dot evolve the test data. So here the simple, just we need to train, fit, and evaluate the model. These three, the model has that kind of AutoML has those kind of features that can auto majority of the coding part. And here the prediction, as you easily obtain the predictions from these kind of models, like a predictor dot predict and other things. And for classification task, you can also predict the class probabilities instead of predicted classes. And it's the one way of doing it. And once it's done, then we need to fit the model and save the model. So for that, like we use a multi-model predictor to load the data, and here is the examples to save the model. So how it's retrieved and the calling function will be done here. And extract embedding, so we need to do the shaping as well here. And once it's done, then we use TNSC to visualize these kind of extraction embeddings, where we can see there are two type of cluster corresponding to our two labels, since the network has been trained to discriminate between these labels. So label 0 and label 1 will be our these are nothing but two kind of embedding that we got the results from the above data set. And once are done, then we move to the sentence similarity task, where we split the data for the training and the test data set. So we use semantic textual similarity benchmarks for our data set, and here the sentence 1, sentence 2 on the score and everything. So here is a dry run of that, and once are done, then we need to let's train the recognition model to predict these scores. So we use the time limit to know the exact time range to obtain a reasonable performance in your application. And once that done, then we go for the test score. Here we can again uh, uh, train and test a model performance, how well it's choosing, whether to compute the matrices like RMSE and the person correlation and the spectrum and correlation kind of thing. And let's say our model to predict the similarity scores between a few sentences. Like here is the sentence 1, sentence 2, and sentence 3 scores of that. That is 2.7, 2 point and other things, where it's the done, like where he trained, he tested and evaluated, and once it's done, like we are checking the scores of it different things, like these are the sentences, and it's successfully predicting the scores of that. And once it's done, then we go to the multilingual problems, where here directly these are kind of a problems where a lot of, according to the SL International and other things, there are more than 7,100 speakers of natural languages, where nowadays data sets are highly multilingual, and there are lots of real world problems so involving in the text in it. So for that reason we use this. And here we need to import the multi install the multi-model predictor, and we need to perform this. And for fine tuning we use a German sub ERT, and for cross-lingual transform we use a English to German. So once we install the autoglue one, then we need import the pandas and scikit-learn. Simply we choose it's for a positive, and it's for a one for positive, zero means a negative. We train the data, and we do the training jobs here. And once it's done, here is the fitting model will be performed here, and evaluate model will also be done in this. So predictive value and the fit model, like all three will be performed in a single code. And once are done, then here the train model to the English data, here is the one, and the fitting model for that, and the two different for the two different data sets. And once are done, then we predict the both accuracy of this. And this is the one part, and the next one is named entity recognition. So here for preparing data, this is our data set or data frames and other things. And so here the named entity recognition, NER, refers to the identifying and categorizing key information that are entities from an unstructured text. An entity can be worded or a series of words which corresponding to categorizes, such as cities, time expressions, mandatory value facilities, or etc. Nerd models usually follows as a input is a annotated block and of a text, and output of an annotated block of a text for highlighting the names entities which are preferred categories. And once the pip install is done, then we import the torch vision audio and other things. So here is the audio and installing of a pip, and here we upgrade the Python, sorry, autoglue one. And once upgradation is done, then we import the data JSON and JSON.dumps. So this is the JSON.dumps file, and here is the visualizer NAR user utility. So here we give annotations here, and once annotation is done, then we load the data into that, and we import the autoglue and loaders and the load PD function to load our data sets and other things. So once are done, then print a row. So here is the text snippet and entity annotation snippet, and here we go for the training data sets. And once the training is done, then we predict and evaluate the functions, and the prediction plus visualization will be done here. And the prediction probabilities will be done performed here. And the reloading and the continuous training is this part, where they have the evaluate and the fit and the other modules here. Load, fit, and the evaluate models will be performed here. And this is about the CNR thing. And once are done, then AutoML for image classifier, where we just import the multimodal predictions.fit, and once the fit is done, then we import the autoglue on installing part, and the vision and the audio will be the torch vision and the torch audio will be installed. Post that we upgrade the autoglue on, or even that we can work. So here the warnings is imported, and the ignore will be neglected as a part of it, and the SHOP data set will be downloaded here. And once the data set is done, then here we can see the data path and training the data and other things, where we can see there are 800 rows on the two columns in the training data frame. These two columns are images and the labels. So the image contains the absolute path of the image, and each represent the different training samples. Like um, for example, this is one training sample, and this is another training sample in this scenario. And once it's done, we use AutoML to fit the model. So here this will be performed here dot fit the AutoML for the fitting purposes. Once that's done, then we move on to evaluate on the test data set. Then it's done, then the prediction will be performed here. And once the prediction is done, then we see the different use case of the image path and the other predictors here. And once that done, then we can go for predict and evaluate functions. Then extract embedding of that, and embedding and save the load, and save the function and how to load it here. We see the things, and here the importing OS and OS model will be deployed here, the model path and other things. So the last one we have the zero shot image classifier with the CLPT. The actually there is a openly introduced model named a CLPT, which can apply to any visual classification benchmark by simply providing the name of the visual categories to be recognized. So that's an example, and CLP has a achieves a 76% to 76.2% top one accuracy on ImageNet without using any 1.8 training and other things. So here is the installation part of that, and once all the installation is done, then we give one random image JPG file, and we ask them to predict on it. So here it can able to predict the normally it's a dog with some kind of toy in it. And then it's done, then we give another example here, these two be able to treat it successfully. Then predict dot images labels, and we give some other wheel, car, bicycle and other things. It can able to predict up to a very good extent. About more about CLP is a powerful and with a design mitigate a number of major problems in this standard deep learning approach to the computer vision, such as the costly data set or costly set production has a poor generalization performance. CLP is a good solution to the many problems. However, it's not the ultimate solution, but CLP has its own limitations. For example, the CLIP is a vulnerable to a typographic attacks. That is, you can add some more text or images to the CLP predictions. It will easily affected by text or something. So here we gave Apple, and here we gave Apple with pasted this thing. So it predicts a wrongly kind of. Here is the same class names to perform zero shot classifications. And it's all about the things where I left it with the one more. It's still under run. Once it's done, I'll attach this video with the previous one, like where it's kind of same steps only, where it's still running on the last model, where I got few errors and other things, like I'll be performing.